Alright, so we want to be able, I can write polynomial equations using the irrational root theorem. Now, what is the irrational root theorem? Um, well, let's solve this equation and see if anything shows up like that. Can we factor this? Can you come up with factors? Like, they would both have to be x minus. Factors of 9 that would add up to 8? Nope, not going to work. So my backup plan, quadratic formula, right? B squared minus 4 times the A value times the C value. Right? 64 take away 36. What is 64 take away 36? Well, 64 take away 30 would be 34. And then if I take away 6 more, that'd be 28. Okay, so we got it. We got it's 28. So we know that the rest of the quadratic formula would be the opposite of B over 2 times A plus or minus square root of 28. Now, I know it's going to go under the radical, right? But why don't we just simply break that up into square root 4, square root 7, right? Because we always want to take the perfect square out. And the largest perfect square I can think of that goes into 28 is 4. So now I can reduce this. And I get, well, what is the first fraction? 8 over 2. That's 4, right? And then plus or minus. Now, we know the square root of 4 is 2. So doesn't that cancel with that, leaving just radical 7? So we have 4 plus radical 7, and we have 4 minus radical 7. These are called irrational conjugates. Just like imaginary solutions are imaginary conjugates when you have things like 2 plus or minus 5i. Now, what is important? What is this irrational root theorem? Let's see if they try to explain it. Well, the roots of a polynomial, x values that make the polynomial equal to 0. Okay, we already know that, right? Irrational conjugates, number pairs of the form a plus or minus radical b. A plus or minus radical b. All right, that looks awkward. I'm going to try to rewrite that. Plus or minus, oops, need to hit the scribble. B. Okay, that looks better. Now, what's the irrational root theorem say? The irrational root theorem says if you know that a plus radical b is a solution, is one of the zeros, one of the roots, okay, then we automatically know that a minus radical b is also a solution, or a root, or a zero. And I know it can be called a zero, an x-intercept, because it's real. It's not a nice number, but at least it's not imaginary. Doesn't have any complex numbers, doesn't have any i's in it, you know. So you could also say if a minus radical b is a root, or is then a plus radical b. So the moral of the story is these things come in conjugate pairs. If you know one, you automatically know the other. So if you're looking at a problem and it says, given roots of a polynomial with rational coefficients, find any additional roots. Well, what's the one that goes with 2 minus radical 5? 2 plus radical 5. What's the one that goes with radical 7? Negative radical 7. Now, notice that each time all I'm doing is changing the sign of the radical part, not the first part, just the radical part. So don't look at me and go, oh, Mr. Stailey, you know, why'd you do that? Well, it's literally me just changing the sign of the radical portion only. Now, if you look at the next example, B, there's no additional roots on B. Now, why is that? Well, because none of the solutions they gave me had radicals in them. I mean, look, it's 4, -3, and 0. Those are all nice numbers. Okay, well, what about this one? Well, obviously, -3 minus square root of 11 and positive radical 29. Those are additional solutions we automatically know. What about this one? Okay, so I would get 4 plus radical 2 and nothing else because 16 is not, there's no radical with a 16, right? So literally that 16 is all by itself. Write the polynomial function in standard form with the given root, negative square root 3. So you immediately know positive square root 3 is also going to be involved, right? Because they come in conjugate pairs. Now, if we know that all factors can be written x minus a number, right? That's how we write every single factor. Then the negative radical 3 should give me x plus radical 3. And the positive radical 3 should give me x minus radical 3. Now, they want it in standard form, so guess what? They want me to FOIL this thing together. Well, I can do that. Copy this one down the side and then start matching things up. X squared, negative x radical 3, positive x radical 3. Oh, look, those two cancel each other out because one's positive and one's negative. And then last and not least, now, we know that's negative square root 9, but what's another way for me to say negative square root 9? We know the square root of 9. Isn't that just negative 3? So the final answer to the question, x squared minus 3. X squared minus 3. Now, when we did differences of perfect squares, this is kind of a side note. When we did, if I asked you to graph or to factor x squared minus 16, you would take the square root, so you'd have x and x, you'd have 4 and 4, one's a plus and one's a minus. Isn't that the same strategy that's going on right here? Except I can't simplify radical 3 because it's a nasty decimal. Yes, that's what's going on. But they were asking me to start with the zeros, start with the roots, and then work my way back to the standard form. Now, they did say polynomial function. So, technically, and I mean very technically, I probably wouldn't count off if you forgot this detail, but it would be y equals x squared minus 3 to be an actual function. It has to have an x and a y. Okay, let's see. Is that enough for this slide? Yep. All right. So what if we have -2? Well, -2 doesn't have a radical, so it doesn't have any fancy, conjugates. But radical 5, well, that's a radical, and so it's got a conjugate, cousin out there or brother that is also a solution. So we have 3 solutions, so we will have 3 factors. And obviously the -2, right? The -2 is going to create x plus 2. And then the radical 5 is going to be x minus radical 5. And then the last one is going to be x plus radical 5. And so I've got to FOIL these things. We do want it to be a polynomial function, so we will want y equals at the end. So just remember that. I'm going to FOIL these two that have the radicals. Now, you and I both know that because we're doing the ones with the radicals and conjugates, those two boxes are going to cancel out. It happens every single time. I mean, yes, if you don't believe me, we've got x radical 5 and negative x radical 5. Every single time those two cancel out. So really, I'm concentrating on this one, x squared, and then this one down here, which is negative radical 25. Now, what else would we call that? just plain old negative 5. So now I have x squared minus 5 times the x plus 2 that we brought from the beginning. And now I need to do another box, right? Remember, if you don't like boxes, don't use boxes. This is just a quick strategy that makes sure you don't lose stuff. So we got x cubed. We got a minus 5x. We got 2x squared and a minus 10. So my final answer, y equals x cubed plus 2x squared minus 5x and a minus 10. Assuming I did all that correctly. Didn't make a quick mistake. Okay, part B, write the polynomial function in standard form with the given root. Okay, so you are expected to know that 5 minus radical 6 has to be involved as well. So definitely polynomial function, right? We know that means y equals. Every factor is written x minus, but these look a little uglier. X minus 5 plus radical 6, x minus 5 minus radical 6. So I'm going to make a recommendation to you. I'm going to make a recommendation that you distribute that first, giving me x minus 5 minus square root 6. And distribute here, x minus 5 plus square root 6. All right, now, I am going to use a box. My box is now going to be a 3 by 3. That's right. Now, if you know how this works, some cool things are going to happen. So you can see I just took this one and slid it down the side. I got x squared. I got minus 5x. And I've got x radical 6. Then on the next row, I got a negative 5x. I got a positive 25. And I got a negative 5 square root 6. On the bottom row, negative x square root 6. And then positive 5 square root 6. And then lastly, I have negative radical 36. What would we normally call that? Yes, negative 6. Now, look at what's going to happen. Every single time, the top right and the bottom left corner of the boxes cancel out. But then there's another pair that cancels out. It happens every single time we do these conjugates together. So literally there are 5 boxes, the 4 in the upper left and the bottom right corner. Okay? So now I know that y is equal to x squared. Then these two can get added together, right? That's minus 10x. These two are like terms and can get added together. 25 minus 6 is 19. That is the answer to this question. Kind of ugly, but that's what it is. Okay, we need to practice with that. So polynomial function, we know it's going to be y equals. It looks like we have negative 2 plus and negative 2 minus radical 13. Okay, so x minus negative 2 plus radical 13 and x minus negative 2 minus radical 13. Okay, so now we're going to do that distributing thing, right? All right, so the negative 1 gets distributed, giving me x plus 2 and a minus radical 13. And do it again, do the distributing, x plus 2 plus radical 13. Okay, and so now we're going to do this foiling thing. Now, if you and I know which ones are canceling, do I have to waste my time? If I know that one and that one are going to cancel, and if I know that one and that one are going to cancel, why waste my time, right? So I got x plus 2 minus square root 13. So x squared, 2x, positive 4, and then down here, negative square root 169, which is also known as negative 13. So now I know my final answer. Y equals x squared minus 4x. That's 4x came from these two. And then 4 minus 13 is a negative 9. There's my final answer. Let's see what's left in this lesson. It's like nothing's left in this lesson. You have a great day. Bye.